All right, you are close to the end of this section, and it is time to discuss several date functions, the ones you will need if you have to manipulate date values to extract number of periods, such as days, months, or years. The first piece of information you need to know is that Excel records dates as a simple number. I have 3 random dates written here. Do you see? They are just numbers for Excel. The base date that's been chosen is the 31st of December, 1899. The 1st of January, 2019 is equal to 43,466 because that many days have passed since then. Okay, good. It is clear what the functions day, month, and year will extract from a cell that contains a date value, right? They will provide the day, month, or year of a cell containing a date. Let's show how they function in practice. Logically, I obtain 1, as the date is the 1st of January, 2019, and we've asked Excel to extract the day. In the cell below, I will extract the month of this date, and the result is 5. Perfect. And finally, in the last cell, I'll use the year function. Awesome. And why would I need to know these 3 functions? Because in some documents, you will have only a date, and you should be able to obtain this numerical version to manipulate the data. You may ask Excel to determine a date based on some given information and according to a certain rule. Imagine I want to obtain a date from the 3 numbers we obtained here. I can write date, fill in the required components, and obtain a date format. Easy, right? What if I wanted to see the date a year ahead? I should type the same formula, but here is a little trick. I will add +1 in the space referring to the year. And analogically, if I want to obtain a date 1 year earlier, I should have written -1. Okay, let's leave +1 for now. The rest I will keep the same. Perfect. Another thing Excel does for you is calculate the distance between 2 dates measured in days. As your intuition suggests, this must not be a problem at all. It calculates the difference between 2 serial numbers. The obtained result could be a valuable output for the calculation of interest rates and other financial variables, like the ones you saw in our previous lecture. All right, what we discussed so far was the basics of date functions. Let's examine a few date functions you haven't seen so far. EO month, deriving from end of month, gives us the last day of a certain month. To define the month we're looking at, we need a start date and several months. If you leave 0 as number of months, logically, you will see the last day of the month of the starting date. This function could be helpful when you need to unify several events and set them at a distance of the same time. For instance, defining maturity or due dates that fall on the last day of the month. Another interesting function is eDate, meaning exact date. It allows you to get the same date in future or past months. So if you would like to visualize the dates when certain payments are made, especially for a term schedule with monthly payments, this function will be helpful. Observe what I just did. I moved 5 months ahead. eDate can show the same date in future or previous years. The trick would be to multiply the number of months by 12. Let's check if that works. Of course it does. To distinguish it from EO month, remember that E-date is used to calculate maturity or due dates that fall on the same day of the month as the day of issuance, not on the last day of the month. Armed with the functions you learned in this lecture, you can save time in a number of situations. Remember to go through the exercise that accompanies this lesson to see more applications of these functions. And again, we won't get tired of saying, thank you for watching.